Good morning, everyone. I am Rithisha from Second Year Metallurgical Department from Government College of Engineering, Salem. So, today I am going to present about the Rockwell hardness test and about the superficial Rockwell hardness test. Before going into the PPT, first let us all know why hardness testing is very important in metallurgy. So, hardness testing is very important in metallurgy because it helps us to understand how the resistance a material is to permanent deformation. So, in case of industries, before using any metal, here the components, we must ensure that it has the required hardness for its application. So that's why hardness testing is playing a very violent and major role in quality control. Now, let us see about the definition of the hardness. So, when we say hardness, we mean that the resistance of a material to indentation or scratching. So, this can be understand very easily from our day-to-day life incidents. For example, if we press our nail into wood, it will go inside slightly, sometimes easily. So, but if we press the same nail into the steel, it will not go inside. So, so this shows that the steel is harder than wood. So, hardness is directly related to the strength and wear resistance. So, the materials used in tools, gears, and machine parts must have proper hardness. So, now let us see about the principle of Rockwell hardness test in our third slide. So, the Rockwell test is based on the depth of indentation. Unlike the other hardness tests like Brinell hardness test, where we measure the diameter of the indentation. In case of the Rockwell hardness test, we will measure how deep the indenter is penetrates. So first, here the minor load of 10 kgf is applied first. Then the major load of 60, 100 and 150 kgf are applied. This ensures a proper contact between the indenter and the specimen. So, after removing the major load, the machine measures the permanent depth of the indentation. If the indentation is deeper, the material is softer. If the indentation is shallow, the material is harder. So, the hardness number is calculated from the depth difference. This is what the principle of Rockwell hardness test. So, next, let us see about the Rockwell hardness formula. So, HR is equal to N minus H divided by S. Here, the HR stands for the Rockwell hardness number, and your N stands for scale constant, and H increases in depth of penetration while S is a scale factor. For example, HRC 60 is for the hard materials. Now, let us see about the Rockwell hardness scales. So, HRC, here there are different Rockwell scales depending on the material type. So, HRC is mainly used for the HRC is used for mainly hardened materials. It uses the diamond cone as an indenter and 150 kgf. Next is HRB, which is used for the soft materials like brass and the mild steel. It uses the steel ball as an indenter and 100 kgf. Next is HRA, which is used for the thin and hard materials. So, the reason for the different scales is that one type of load and indenter is not suitable for all materials. So, such that softer materials will require lower load and as a ball indenter, while the hardened materials require diamond indenter. So, these are about the scales of the Rockwell hardness test. Next, the applications. So, the Rockwell test is widely used in industries like automotive, aerospace, and tool manufacturing, etc. So it is used to test the gears, shafts, bearings, cutting tools and heat treated components. Here The main advantages are it is quick, it gives direct reading, it does not require microscopic measurement. It is suitable for mass production. So, because of these advantages, it is one of the most commonly used hardness test. Next, we come with superficial hardness. Now, I will explain the superficial hardness test. It is a modified version of the standard Rockwell test. So, the principle is of the same. Here, it measures the depth of the penetration, but the difference is the load applied. It is the in case of the standard Rockwell test, the loads are higher if we use the same load on the thin sheets or the small components. The indentation may be too deep and it may damage the materials. So, in superficial testing, the minor load is of 3 kgf and we apply the major load is of 15, 30 and 45 kgf. Because the load is smaller, the indentation is shallow. That is lower total load compared to the standard test. So, here we are applying the load is lower comparing to the standard Rockwell test. This test is especially useful for thin metal sheets, case-handled surfaces, then small precision parts and coated materials. For example, if a compound has a thin hardened surfaces, the standard Rockwell test may penetrate beyond the hardened layer and give wrong reading. But in case of superficial hardness testing, it measures only the surface layer hardness accurately. Now, let us see about the superficial Rockwell scales. So, in superficial testing, we have scales like HR15N, HR30N, HR45N. Here, they are used for the hardened materials, and here the diamond is used as an indenter, and such that HR15T, HR30T, HR45T. Here, it is used for the softer materials, and here the steel ball is used as an indenter. So, here the number indicates the major load is used. So, from this, now we will see about the applications and advantages of the superficial Rockwell hardness test. So, the applications it include, so heat treated components testings, tools and die inspections, automotive and aerospace parts, thin sheets and case handled surfaces, small precision components, quality control in industries. So these are the applications of the superficial hardness testing. Then advantages: quick and simple testing, direct reading of the hardness value, no need to measure the indentation of the diameter, suitable for mass production testing, and minimal surface damage in superficial testing. So these are the application and advantages of the superficial Rockwell hardness test. Now, from this we have seen about the two types of hardness testing. One is Rockwell standard Rockwell hardness testing, another one is superficial Rockwell hardness testing. From these two, now I want to conclude is to conclude, the Rockwell hardness test is simple, fast, and widely used in the industries. So, it measures the hardness based on the depth of indentation. Then, when we come to the superficial Rockwell hardness testing, it is specially designed for the thin and delicate materials. Here, the both tests are essential in ensuring the product quality and reliability in manufacturing the industries. So, the two hardness tests are very useful for the industrial purposes, and they are providing a vital role in our day to day life to check which material has much resistance against the hardness. And so that thank you for this opportunity, and thank you for your valuable time to watch this video. From this, Thank you.